Hi guys, this is lecture 3.2, maximum and minimum on an interval. When we're asked to find the maximum or minimum, or as we call it, the extreme values of a function, there are several procedures. The first thing that we have to do is when we're given a function f of x, we have to find out if a derivative exists at every point in the interval a to b. If it does exist, and most of the time it will, then we have to calculate f of x at all the points in the interval from a to b, where the derivative of f of x will be equal to 0. Then we have to calculate the f of x at the endpoints, where x is equal to a and x is equal to b. The maximum value of f of x at the interval a to b is the largest of all of these values, and the minimum value is the smallest. In procedure 2, we mentioned that we have to calculate f of x, the derivative of f of x equal to 0, because that actually gives us the slope of tangent at a certain point on the graph. And in this graph, you see when the slope of tangent is equal to 0, we get a maximum. And for the other point, where the slope of tangent is equal to 0, we get a minimum. However, once in a while, we get these clever graphs where the maximum and the minimum are not at where the derivative of f of x equal to 0 is, as you can see on the right here. The maximum actually occurs at the endpoints, in this case x equals to a, and the minimum occurs at x equals to b. So in this case, we also have to test out the endpoints when x is equal to a and x is equal to b, and that would be the third step, and calculate what f of x is. Let's take a look at example 1 from Learning Resources. Find the maximum and minimum of the function f of x equals to x cubed plus 6x squared plus 9x plus 2 in the interval of negative 3.5 less or equal to x less or equal to 1. So the first thing we have to do is find the derivative of f of x. And we have to let the derivative be equal to 0, so we can find the horizontal slope of tangent. And when we do that, we find that x is equal to negative 3 and negative 1. Next, what we have to do is we have to find f of x for when x is equal to negative 3, negative 1, as well as the endpoints being negative 3.5 and 1. When x is equal to negative 3, f of x will be equal to 2, and we find that by substituting negative 3 instead of x in this original equation. When x is equal to negative 1, we get f of x is equal to negative 2, and so on. We also have to calculate this for the endpoints. And after we do that, we have to compare and contrast these f of x answers. We have to find the maximum value for the f of x as well as the minimum value. And in this case, the maximum value will be 18, and the minimum value is negative 2. So we say the maximum occurs when x is equal to 1, and the minimum occurs when x is equal to negative 1. And that will be our final answer. Now let's take a look at example 2. The amount of current in amperes, A, in an electrical system is given by the function c of t equals negative t cubed plus t squared plus 21t, where t is the time in seconds, and in between 0 and 5. Determine the time at which the current is at its maximum and minimum, and determine the amount of current in the system at these times. So once again, we have to start out step by step with the procedure. So the first procedure asks us to find the derivative of c of t. Sorry, this should actually be, let me just change that. So the derivative of c of t equals to negative 3t squared plus 2t plus 21. The next, what we have to do is we let this derivative of c of t be equal to 0, and we solve for t. T will be either negative 7 over 3 or 3. We already set the interval that t is supposed to be in between 0 and 5. Therefore, negative 7 over 3 is not in this interval. and this answer is rejected. Now what we have to do is check what does C of t equal at the endpoints as well as at t is equal to 3. So one of the endpoints is 0. When t is equal to 0, C of t is equal to 0. When t is equal to 3, and that's the answer that we calculated over here, C of t is equal to 45. And when t is 5, we get C of t is equal to 5. We said that maximum occurs at t equals to 3 seconds, and it is 45 amperes, and the minimum is 0 amperes at the time t equals to 0 seconds. And that's the